Hello friends, let us start with a new topic, that is equivalent circuits. In this video, we will understand how to find equivalent resistances in given 2 points. Let us begin. So the problem is appeared on the screen. You have to find R between two terminals which are A and B. So right now, you have to always see whether you have a scope for finding the resistances in series or in parallel. As you can see, there is no scope for reducing resistances in series or parallel. So what we can preferably do in this is delta to star conversion. As you can see, if I talk about this R, there is nothing in series with this. So what we will do is, we will convert this delta which is formed by R and R into star. So if I do so, I should get another star here. We know how to convert delta to star. So instead of referring to the formula, try to understand all the values are R and they are asking us to assume resistance value as 1. It means all the resistances are equal. So this is quite a shortcut to remember. Whenever you are converting delta to star and every delta element is having equal value, let's say R, then the resultant star is always every element with R by 3, R by 3 and R by 3. So whatever I said, I'll just put it on the screen. Suppose you have a delta having every element as R, R and R, then the resultant star will have also 3 elements having values as R by 3, R by 3 and R by 3. So suppose every element is, let's say, 9 ohms, 9 ohms and 9 ohms, then every element in the star will become 3 ohms, 3 ohms and 3 ohms and so on. So now we have decided to convert the inner delta into equivalent star, where star is having all the values as R, R, R. So everything now will become R by 3, R by 3 and R by 3. So I will first of all draw the outer delta first. Inside this, we already had R. We already had R here and we have one more R here. And the inner delta got converted into equivalent star, which was R by 3, R by 3 and R by 3. Now what we can see surprisingly, R by 3, R by 3, R by 3 in every arm are connected in series. So we can now have an equivalent resistances there, that is R plus R by 3. Effectively, R plus R by 3 will become 4R by 3. So now we can replace every star element with equivalent resistances as 4R by 3. And we can redraw the circuit as so. The outer element was R formed with the delta having 2 points A and B here, and the equivalent star inside this will have equal values as 4R by 3. So every value inside this is 4R by 3. Further, what I can do is, I can convert this star back to delta. So whenever you are converting star to delta, rather than referring the standard formula, we can have one more shortcut in this case, because every element is an equal element. So if you remember, in the last slide, I said that whenever you are converting delta to star, and let's say delta is having every element as an equal element, then let's say as R, then equivalent star becomes R by 3 and R by 3. Similarly, now we have exactly reverse case. The given network is a star having equal elements, let's say R, R and R, then its equivalent delta becomes 3R, 3R and 3R. Whatever I said, just let me draw this. So let's say when we have a star having all equal elements, then its equivalent delta will have elements as 3R, 3R and 3R. So here every element is 4R by 3, so every 4R by 3 gets multiplied with 3, becomes 4R, 4R and 4R. Now we can redraw the circuit as A and B had this delta, all of them were R. Now this star gets converted into delta. Effectively, what we have, delta present here. As you can see, the delta which I have drawn with blue color will have values as 4R, 4R and 4R. So this value was R and value inside this resistor is 4R. In effect, what I can see is this is R parallel with 4R. So 4R, here it will be a parallel connection with 4R, and here we have one more connection as 4R. Effectively, R and 4R comes in parallel. So because of the parallel connection, now effective for every arm will be R into 4R divided by R plus 4R, which becomes 4 upon 5 times R. So now every impedance or every element of the delta becomes 4 by 5 R. Therefore, I can redraw the circuit like this. This is 4 by 5R. This is also 4 by 5R. And last, this is also 4 by 5R. And we had 2 points A and B. We have to find an equivalent resistance between A and B. So what we can see is this 4 by 5R and this 4 by 5R are in series. Therefore, the addition becomes 8 by 5R. So I can now say that RAB will be equal to 4 by 5R, which comes in parallel with the series combination of this, which is 8 by 5R. Therefore, equivalent becomes 4 by 5 multiplied by 8 by 5 divided by 4 by 5 plus 8 by 5, which becomes 32 by 25 multiplied by 5 by 12. So now it becomes 32 by 60 times R. Let us see the value of R. If you refer that circuit, the value of R was 1 ohms. Effectively, now the value of RAB will be equal to 32 by 60 times R. Since R value will be equal to 1, it is simply 32 by 60 ohms. I'm sure now you have understood this problem. With this, now we can start with problem number 2. So in problem number 2 also, they are going to ask you the same, that is the value of equivalent resistance between these 2 points, which is A and B. As I said, you have to always see whether if there is any scope for reducing resistances in series or resistances in parallel. So as you can see, there is absolutely no such scope. But what we can see is there is a short circuit across this resistance. Please understand, whenever there is a short circuit across a resistance, that particular resistance becomes a redundant. Redundant means you don't have to redraw that circuit again. redundant means that resistance we don't have to draw in the circuit. We can in fact remove that resistance from the circuit. Effectively, I have to draw an equivalent circuit, but sometimes it happens that it is quite difficult to redraw the circuit because of the circuit complexity. In this, one method helps you, which is called as a point method. Let us understand how to deal with point method. See, if this point is A, I can consider this point as A. If this point is B, I can consider the same point as B because they are directly shorted. I can see this point as also B. This point is also a B. Since this point and this point are directly shorted, so I can consider this point as B itself. Now, as you can see, if these points are A, these points are B, this point is nowhere connected to A or B, so rather I should say that this point is, let's say, C. So in totality, you got 3 points A, B and C where you have to find an equivalent circuit between A and B. So what I'll do is, I'll say A point here and B point here, across which I had to find an equivalent resistance, and there was one more point which is intermediate point which I will consider somewhere here. And now let's start drawing the circuit. As you can see, there is a 2 ohms resistance connected between A and C. Observe, this 2 ohms connected between A and C. So I'll draw that 2 ohms now. Next, 3 ohms is connected between B and C. So 3 ohms is connected between B and C. After that, 6 ohms is connected between B and C. So 6 ohms is connected between B and C. So 2 ohms is drawn, 3 ohms is drawn, 6 ohms is also drawn. The 4 ohms is already redundant, so we need not to consider that. Now 3 parallel with 6 will give you 2 ohms. So effective circuit becomes 2 ohms connected in series with 2 ohms. So RAB equivalent circuit will be 2 in series with 2. So effective value of RAB will be equal to 4 ohms. So this was problem number 2. Let us start with our next problem. In this problem also, we have to find an R equivalent between A and B points. So assume this is A and this is B point. As you can see, like a previous problem, there is again a complex problem. A complex circuit can be solved very easily by using a point method. So if this point is B, I can consider this point as B. I can consider this point as B. I can consider this point as B. As you can see, this point and this point are directly shorted. I can claim this is also B. Then in turn, this is also B. If this point is A, then this point is also A. This is also A. This is also A. In that case, this also becomes A. And as you can see, these are also connected. So this is also A. So if you see, there is no other point other than A and B, meaning that every resistor specified here is connected between A and B. Rather, I can claim that every resistor is parallel to each other because every resistor connected between A and B. If I draw that A and B line, check it out. This 12 ohms is connected between A and B. We have drawn that. 4 ohms is connected between A and B. After that, 2 ohms is connected between A and B. 12 ohms is connected between A and B. 12 ohms is also connected between A and B. In fact, when 12 parallel to 12 combination is there, when 2 equal resistances are parallel to each other, effective is always half of it. So I can say it is simply 6 ohms. So 4 parallel with 12 is 3. Is in parallel with 6, is in parallel with 2, and this becomes total circuit between A and B. So 3 parallel to 6 is 2 and 2 parallel to 2 is again 1 ohms. Effectively, I can say that the value of RAB is equal to 1 ohms. So this is how we solve the problems with the help of point method. Let us go to the next problem. Again, in this problem, we will try to solve it by point method only. See, if this point is A, this point I can say this as A. If this point is B, I can say this point is B. Now as you can see, this is directly shorted. I can claim this is B. If this is A, this has to be treated as A. Again, as we have seen in the last problem, there are only 2 points A and B, and every resistor is connected between A and B. So as you can see, every resistor, like a previous problem, is connected between 2 points only, that is A and B. So if you talk about 4 ohms, it is connected between A and B. Then 6 ohms is connected between A and B. And the last 12 ohms is also connected between A and B. So if you take 4 parallel with 6 parallel with 12 combination, you will get 2 ohms as equivalent resistance between A and B. So RAB in this case is simply 2 ohms. With this, now we can start with the next problem. In this problem also, we will try to go for point method only for finding equivalent resistance between A and B points. Assume A and B here. So if I say this is A point, this is B point. So if I assume this is C point, this has to be C point. Again, total points are 3, that is A, B and C. The equivalent resistance needs to be found for A and B. So A and B to be taken as extreme points, and intermediate to this C point will be taken. So this 3 ohms is connected between A and C. 6 ohms is connected between again A and C. After that, 12 ohms is connected between B and C. And the remaining 6 ohms is also connected between B and C. So if you take a parallel combination of 3 parallel with 6, which will give you 3 into 6 upon 3 plus 6, which comes out to be 2 ohms. Whereas if you take a parallel combination of this, which becomes 12 into 6 upon 12 plus 6, which effectively comes as 4. Then 2 ohms and 4 ohms comes in series. Effectively you get RAB equal to 2 plus 4, which is 6 ohms. With this, now we will go for next problem. Again, in this we have to find an equivalent resistance between A and B. Now if you go for point method, you will find that no 2 points are same. For example, if this is A and this is B, this is neither A nor B, let's say it is C. If this point is C, this cannot be C, A as well as B, so this has to be D. Meaning that this circuit consists of total 4 points A, B, C and D. So again, I have to find equivalent resistance between A and B. C and D are intermediate points. Let me have C here and D here. And I will be finding resistances between A and B. Let us try to redraw the circuit or simplify the circuit. 3 ohms is connected between A and C. 1 ohms is connected between C and D. 3 ohms is connected between B and D. 3 ohms is connected between B and C. Whereas the remaining 3 ohms is connected between A and D. These are 2 points across which we have to find an equivalent resistance, which is RAB. If you have seen this circuit, it is nothing but forming a bridge. This is called as a typical bridge circuit. And if you observe it carefully, you will find that this is a balanced bridge. How do we find balanced bridge? We take the ratios of adjacent resistances, like this 3 ohms divided by 3 ohms becomes 1. Similarly, this 3 divided by 3 becomes 1. It means this is called as a balanced bridge. And in balanced bridge, every point or a diagonally opposite point are considered to be equipotential point, meaning that this point C and point D is equipotential point. Equipotential point means between which the current cannot flow, meaning that through this 1 ohms the current is not going to flow, so this resistance becomes a redundant one. And since it has become redundant, now the equivalent circuit can be drawn as, this was point A, this was point B, this was point C, and this is point D. Every resistance stated over here having equal values 3 ohms. So now these two resistance in a upper branch are in series, become 6 ohms. In the lower branch it is 6 ohms. In effect we have got 6 ohms parallel with 6 ohms, effectively it becomes 3 ohms. So RAB is now equal to 3 ohms. So I'm now sure you have understood it very well how to use point method for finding an equivalent resistances between 2 points, let's say A and B. Thank you so much for watching this video. Stay tuned with Ekeeda. Subscribe to Ekeeda.